Right now, while you are reading these words, a team of scientists at NASA is looking at a map that should not exist. It is a map of something hidden nearly 200 miles beneath the surface of the moon, something so large and so strange that when the data first came in, researchers assumed their instruments had made a mistake. They checked the numbers 3 times. They were not wrong. Buried beneath the far side of the moon, in the oldest and deepest scar in the entire solar system, there is a mass of material so dense that it is bending the moon's gravity around it. It is not a cave. It is not a pocket of ice. It is not a rock formation anyone expected to find. It is something with the mass of 5 quintillion kilograms hidden below one of the most violent impact sites ever recorded, sitting there silently for possibly billions of years, waiting for us to finally build a mission capable of looking closely enough to notice it. And here is the part almost nobody is talking about. This discovery did not stay a footnote in a journal. It became one of the reasons NASA redesigned where the Artemis astronauts are going to land, what they are going to search for, and what they might actually find when human boots touch the lunar surface again for the first time in more than 50 years. This is the story of what the Artemis mission has already found beneath the moon before a single astronaut has even landed. And by the time this is over, you will understand why the next few years of lunar exploration may end up rewriting our understanding of how the moon, and possibly Earth, actually came to exist. I am Your Name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. Let's go back to the beginning. For most of human history, the moon was treated as a settled subject. We had been there. We had walked on it. Between 1969 and 1972, 12 astronauts left footprints on its surface during the Apollo missions, collected rocks, planted flags, and came home. And then, for decades, humanity simply stopped going. Robotic missions continued. Orbiters mapped the surface in greater and greater detail, but the era of humans physically standing on the moon quietly closed. The general public assumption became that the moon was a solved problem, gray, dead, cratered, and fully understood. What almost nobody outside the scientific community realized is that the more closely we looked at the moon using modern instruments, the less settled it actually became. Every new orbiter, every new radar sweep, every new gravity measurement kept turning up details that did not fit the simple picture most people carried in their heads. And it was against that backdrop in the early 2020s that NASA formally committed to the Artemis program, a mission designed not just to repeat what Apollo did, but to go somewhere Apollo never dared to go, the lunar South Pole. The south pole of the moon is unlike anywhere the Apollo astronauts ever walked. Because of the angle of the moon's axis, certain deep craters near the pole never receive direct sunlight. Not for a day, not for a year, but for possibly billions of years. Scientists call these permanently shadowed regions. And inside them, temperatures drop low enough to trap and preserve substances that would evaporate almost anywhere else on the lunar surface. In 2009, a NASA mission called LCROSS deliberately crashed a spent rocket stage into one of these shadowed craters and watched the debris plume for signs of water. What it found confirmed something scientists had suspected for years, but never proven. There was water ice at the bottom of that crater, locked in permanent darkness, undisturbed for what may be an extraordinarily long stretch of lunar history. That discovery alone would have been enough to justify decades of follow-up missions. But it was only the beginning of what the South Pole was hiding. Over the following years, additional missions added more pieces to the picture. India's Chandrayaan missions detected signs of water molecules spread more broadly across the lunar surface than anyone expected. Not just trapped in shadowed craters, but bound into the very minerals of the regolith itself. NASA's Lunar Reconnaissance orbiter, which has been circling the moon since 2009, used radar and neutron spectrometers to map out where ice deposits were most likely to be concentrated, gradually building a picture of the South Pole as something closer to a frozen reservoir than a barren wasteland. This is the environment Artemis was designed to explore. Not the flat, sunlit plains where Apollo landed, but the harsh, shadowed, resource-rich terrain near the pole, where ice deposits could one day support a long-term human presence, and where, as it turned out, something far stranger than ice was waiting to be found. Artemis Lunar launched in November 2022, an uncrewed test flight designed to prove that the new Orion spacecraft and the Space Launch System rocket could safely carry astronauts to the moon and back. It worked. Orion flew farther from Earth than any spacecraft built for humans had ever traveled, looped around the moon, and returned safely to Earth, splashing down in the Pacific Ocean after a 25-day mission. It was, by every measure, a success. But while the world was watching the rocket, a separate and far quieter discovery was unfolding in the data being pulled from decades of lunar orbital surveys, one that had almost nothing to do with rockets or capsules, and everything to do with what lay far beneath the moon's visible surface. Here is where the story takes its first real turn. In 2023, a team of researchers, including scientists from Baylor University, published findings based on gravity data collected years earlier by NASA's GRAIL mission, two small spacecraft that had orbited the moon in tandem, measuring tiny variations in its gravitational field with extraordinary precision. Gravity is not uniform across a planetary body. Denser material pulls slightly harder. Less dense material pulls slightly less. By tracking these subtle differences with extreme sensitivity, scientists can essentially build an X-ray of what lies beneath the surface without ever having to dig. And when researchers pointed this gravitational X-ray at the far side of the moon, specifically at the floor of the South Pole Aitken Basin, one of the oldest and largest impact craters in the entire solar system, stretching roughly 1,300 miles across, they found something that did not belong there. Beneath the floor of that ancient basin sits a mass of unusually dense material, embedded roughly 160 miles below the surface, with an estimated mass of around 2.18 million cubic kilometers of extra material, translating to a mass increase on the order of quintillions of kilograms concentrated in that one region. To put that scale in perspective, researchers described it as being large enough that if it were spread evenly across the entire basin floor, it would form a layer more than half a mile thick. This is not a small anomaly buried in noisy data. This is one of the largest unexplained mass concentrations ever detected inside a rocky body in our solar system. And the leading explanation researchers have proposed is almost as strange as the discovery itself. It may be the remnant core of the asteroid or planetary fragment that slammed into the moon and carved out the South Pole Aitken Basin in the first place. An impact so ancient it likely occurred more than 4 billion years ago, back when the solar system itself was still a chaotic, violent, newly forming place. If that explanation is correct, then buried beneath the moon's oldest and largest scar is quite possibly the metallic heart of the very object that created that scar, a piece of another world entombed inside our own for over 4 billion years. Think about what that actually means. This is not a rock. This is not a mineral deposit. This may be a fragment of an entirely separate cosmic body, the surviving core of beneath lunar soil since a period in solar system history before Earth even had continents, before life, as we understand it, had taken hold anywhere in our corner of the galaxy. And it was sitting there the entire time human beings looked up at the moon with the naked eye, through telescopes, and eventually from the surface itself during Apollo, completely undetectable until the right instruments, at the right sensitivity, mapped its gravitational fingerprint from orbit. But the South Pole Aitken mass anomaly was not the only thing hiding beneath the surface. In 2024, a separate team of researchers, using decades of radar data from the Lunar Reconnaissance orbiter, identified something else entirely. This time, much closer to the surface and far more directly relevant to future human exploration. Inside a deep, steep-walled pit located in Mare Tranquillitatis, the same general region where Apollo 11 first landed, radar signals revealed evidence of what appears to be an intact, undamaged lava tube extending outward from beneath the pit, likely stretching for a significant distance underground. Lava tubes form when molten rock flows beneath a hardened surface crust and then drains away, leaving a long, cave-like tunnel behind. On the moon, without the erosion and structural weathering that breaks down similar formations on Earth, these tubes could remain remarkably stable, potentially wide enough and long enough to essentially function as a natural underground shelter. For engineers thinking about long-term human presence on the moon, this discovery mattered immediately. The lunar surface offers no atmosphere, no magnetic shielding, and almost no protection from cosmic radiation, solar radiation, or the constant bombardment of micrometeorites. Building livable structures directly on the surface means solving all of those problems using imported shielding material, added mass, added cost, and added risk. A naturally occurring underground tunnel, stable, insulated, and already shielded by dozens of meters of solid rock, could solve several of those problems at once without a single astronaut needing to pour a foundation. What began as a radar anomaly in old orbital data quietly became one of the more serious candidates for where a future lunar base might actually be built, not on the surface at all, but underneath it. And then there is the layer of mystery that predates both of these findings and that scientists still cannot fully explain. The lunar swirls, scattered across the moon's surface, mostly on the near side, are strange, pale, looping patterns that look almost like they were painted onto the ground, some stretching for dozens of miles in intricate, swirling shapes that follow no obvious geological logic. The most famous of these, called Reiner Gamma, has puzzled scientists for decades. What researchers eventually discovered is that these swirls correspond almost exactly to small, localized patches of magnetic field on the moon's surface, patches that are strange in themselves because the moon, unlike Earth, does not currently generate a global magnetic field of its own. Somehow, in specific isolated regions, tiny pockets of magnetism remain, deflecting the constant stream of charged solar particles that would otherwise darken the surface, leaving behind the pale, swirling patterns where the deflection occurs. Nobody has definitively proven where these localized magnetic fields come from. Some researchers suspect they are linked to buried metallic deposits, possibly connected to the same category of ancient impact material, responsible for the mass anomaly beneath the South Pole Aitken Basin. Others believe they may be remnants of a magnetic field the moon once generated on its own, billions of years ago, before its core cooled and that global field shut down. Either explanation points toward the same underlying truth. There is more buried structure inside the moon, unexplained and unmapped, than the simple gray, dead, geologically inactive picture most people carry in their heads. Now, let's talk about what happened next, because the path to actually reaching these discoveries in person has not been smooth. In 2024, NASA made a decision that disappointed much of the lunar science community. Viper, the Volatiles investigating polar exploration rover, a mobile robot specifically designed to drive into the permanently shadowed regions near the South Pole and directly sample the water ice deposits detected years earlier, was canceled before it ever launched. The rover was fully built. Engineers had spent years designing and assembling it. But rising costs, schedule delays, and constrained budgets led NASA to cancel the mission just months before its planned launch window, redirecting the hardware toward possible commercial partnerships instead of an outright NASA-led mission. For a program built around the promise of the South Pole's hidden resources, losing the one robot specifically designed to touch and analyze that ice directly was a significant setback, and it forced planners to rely even more heavily on orbital data and the eventual arrival of human astronauts to fill in the gaps Viper was meant to close. The cancellation did not end the search for lunar ice. It simply changed who would be doing the searching. NASA has continued to lean on commercial partners through its Commercial Lunar Payload Services program, contracting private companies to deliver smaller robotic landers and instruments to the surface ahead of any crewed mission, each one adding another small piece to the picture of what the South Pole actually contains. Some of those landers have carried drills designed to sample the top layers of regolith. Others have carried spectrometers designed to detect water molecules bound directly into the soil rather than sitting as visible ice. Piece by piece, mission by mission, the picture of the South Pole has grown more detailed, even without the one rover that was originally built, to do the job directly. It is a slower, more fragmented approach than a single dedicated rover would have offered, but it has kept the underlying question alive. How much water is actually down there? How accessible is it, and how much of it could realistically support human life during future Artemis missions? That pressure is exactly why the destination decisions for Artemis III matter so much. Unlike Apollo, which landed on relatively flat, well-lit equatorial plains, chosen primarily for safety, Artemis III is targeting landing sites clustered around the lunar South Pole in the same shadowed, ice-rich, gravitationally strange terrain where these discoveries keep emerging. NASA has narrowed the candidate landing zones to a handful of sites, near features like Shackleton Crater and the ridges surrounding the Degerlash Crater, regions chosen specifically because they offer both extended sunlight for solar power and close proximity to permanently shadowed areas believed to contain accessible ice. When Artemis astronauts finally step onto the lunar surface, they will not simply be recreating a historical moment. They will be walking within reach of one of the most scientifically loaded regions of the entire moon, sitting almost directly above the ancient basin where that quintillion kilogram mass anomaly waits far below, and within range of some of the very shadowed craters believed to hold billions of years of preserved ice. Here is what is happening right now in 2026, because the story is very much still unfolding. Artemis II, the first crewed mission of the program, is on the calendar to carry a crew of 4 astronauts on a journey around the moon, testing every system required to keep humans alive on the long journey out and back, without yet attempting a landing. It is the critical proving ground standing between where the program is today and the actual crewed lunar landing planned for Artemis III. Every delay, every technical review, every safety check between now and launch matters enormously because the entire architecture built around exploring the South Pole's hidden resources depends on getting human beings safely to the surface and back. Behind the scenes, engineering teams are working through spacesuit development, lander testing with commercial partners, and the enormous logistical puzzle of keeping astronauts alive and productive in one of the harshest environments human beings have ever attempted to work in. And that brings us to the part of this story that deserves to sit at the center of everything. Because right now, in 2026, we already know more about what is hidden beneath the moon's surface than the astronauts who once walked across it ever did. We know there is a mass of unexplained density, possibly the metallic remnant of an ancient cosmic collision buried nearly 200 miles beneath the oldest impact basin in the solar system. We know there are lava tubes stable enough to potentially shelter future explorers, hidden just beneath pits that were sitting in plain sight the entire time Apollo astronauts explored the region nearby. We know there are patches of localized magnetism carving pale, swirling patterns into the surface, hinting at buried structure nobody has fully explained. And we know that the very ice deposits capable of sustaining a long-term human presence are locked inside craters that have not seen direct sunlight for possibly billions of years, waiting in absolute darkness for the first human hand or the first rover capable of finally reaching them. None of this was visible to the naked eye. None of this was detectable from Earth with any telescope built before the space age. It took gravity satellites flying in careful formation, radar systems bouncing signals off buried cave ceilings, and magnetic field sensors sensitive enough to detect the faintest whisper of a field that should not exist on a geologically dead world. Every single one of these discoveries came from instruments built by people who were simply patient enough and curious enough to keep looking closer at something the rest of the world had already decided was fully understood. There is a real possibility that when Artemis astronauts finally stand at the lunar South Pole, walk across ground shaped by an impact more than 4 billion years old, and look down at craters that have never once seen sunlight, they will be standing directly above. Evidence that helps answer one of the oldest open questions in planetary science, how worlds like our own moon, and by extension worlds like Earth, actually came to be built. The material buried beneath that ancient basin may hold direct physical evidence of the violent, chaotic process of planetary formation itself, the very collisions and mergers that built rocky worlds out of the debris left over from the birth of the sun. Understanding what that buried mass actually is, whether it is truly the metallic core of an ancient impactor or something else entirely, could reshape our understanding of how frequently and how violently young planets like Earth once collided with the debris still swirling around them. The moon has been sitting 63,000 miles closer to us than any planet in the solar system for the entire span of human civilization. We named it, worshipped it, mapped its surface by eye centuries before we understood what it actually was, and eventually walked across it. And after all of that, it turns out we had barely scratched its surface, in the most literal sense possible. There is a hidden world beneath the visible one, dense mass, ancient impact remnants, stable underground caverns, and pockets of magnetism nobody can fully explain, all sitting quietly beneath the ground. The next generation of astronauts is about to walk on. There's also an international dimension to all of this that is easy to overlook. Artemis is not a NASA-only endeavor. Under the Artemis Accords, dozens of countries have signed on to a shared set of principles for exploring the moon, and multiple space agencies around the world are now flying their own orbiters, landers, and instruments toward the same South Pole region NASA is targeting. That means the picture of what lies beneath the lunar surface is being built not by a single country working in isolation, but by a growing global effort, each mission adding another layer of gravity data, another radar sweep, another magnetic reading to the same unfolding puzzle. In a strange way, the moon has become one of the few places where the search for answers is happening faster because more of humanity is looking at once. The question at the center of all of this is simple, and nobody has been able to answer it yet. What exactly is buried beneath the South Pole Aitken Basin, and what will it tell us once human explorers and their instruments are finally standing close enough to find out? The mission is already in motion. The landing sites are already being chosen with this hidden structure in mind. And sometime in the coming years, for the first time since the final Apollo mission left the surface in 1972, human footprints will once again mark the lunar dust, this time within reach of a discovery that has been waiting in the dark for over 4 billion years. If this kind of story is what you come here for, subscribe right now and turn on notifications, because we are going deeper into the edges of what science actually knows next time. Drop a comment with what surprised you most in this video, and share this with someone who needs to hear it, because this story deserves more than the silence it is getting.